Okay, so we're going to get started tonight. About the first half an hour or so, I want to finish off our discussion of conics. Okay, I've got a little bit more to do, new stuff. And then I want to spend the rest of tonight and all of tomorrow night reviewing for exam 4, which will be this coming Thursday at Mesa College in our classroom. Okay, I've said repeatedly, you can use a 3x5 note card. People who showed up last Thursday, I gave them a note card. I'll have one for you to fill out if you want one, or if you have, I hope you have your own. But Thursday, exam number 4, which is primarily chapter 11 and some other stuff. So I want to get into this last topic and then start reviewing. An intensive review, like I said. I hope you brought some coffee or something. Okay, there's a video that I put right at the start of the module, which should have explained where conics come from. Basically, if you take a cone, okay, and put two cones end to end, and then start slicing them with you take your lightsaber, boom, and the angle at which you slice them, and then you open the thing up and look at it, creates one of these shapes. If you slice it straight up and down, you might have a hyperbola. If you slice it at an angle, okay, you might have an ellipse. If you put it this way, you might end up getting a circle. Again, that video was pretty good. If you really care about it, there are other videos on YouTube. Okay, but that's why they're called conics, because they come from cones, slicing of cones. Now, the first conic, and this is kind of what you guys have to have, is a line. Okay, and we've been studying lines for the whole semester and before. Notice in the equation of a line, there are no powers. X and Y have a power of 1. Okay, these are conics, power of 1. Then we studied parabolas, and we're going to go into more detail on parabolas or more review. But notice the key feature of a parabola is, in this problem, Y does not have a power, X does. So if you strip away all the BS, this is essentially Y equals X squared. Okay, again, stripping away all the fancy stuff up there, this is Y equals X squared. It's an up parabola. Okay, again, this one down here, if you look at it very carefully, this is essentially X equals Y squared. Okay, this is a this is a sideways parabola. Okay, so lines have no powers. Parabolas, only one of the variables is to the second power. The other variable is to the first power. Then we started actually conics starting with circles. And you notice basically a circle has an X squared and a Y squared and an R squared. Basically, a circle says the X is squared, the Y is squared. Really important feature, two features. First, there's a plus in front of it. And secondly, the coefficient of the X squared and Y squared is the same. Most of the time, it's a 1. But as long as they're the same. So X to the second power, Y to the second power, plus sign, coefficient is the same, makes it a circle. If you compare it against an ellipse, it's still X to the second power, Y to the second power, okay? And in this case, it equals 1, but whatever. But in this case, the coefficients are different from each other. The little a and the b number down here is what makes the coefficients different. Okay, the extra stuff down at the bottom. So notice a circle and an ellipse are pretty much the same. Pretty much. They both have variables that are being squared. They both have plus signs in the middle. The only real difference is the coefficients of the x squared and y squared are the same in a circle. The coefficients of the x squared and y squared are different for an ellipse. Okay, so that's a basic review of what we've done so far. And like I said, tonight I will have some more review problems that we can practice tonight and tomorrow night. What I've left off is something called a hyperbola. Okay, I've left it off for a couple reasons. Number one, well, we have to talk about it, but not in a whole bunch of detail. It's part of conics. But for the life of me, I haven't seen it. Maybe once in a long, long while have I seen it as an important topic in future classes. Okay, yeah, in future classes, you'll be graphing lines and parabolas and circles and ellipses up the yin-yang. Those are important. Okay, you'll be doing those a lot. I haven't seen too much of the hyperbolas in future classes. I mean, maybe some teacher likes them a lot. I don't know, but I haven't seen it. So I want to spend a few minutes talking about hyperbolas. Notice there's 3 versions of it. Okay, so let's do hyperbolas. Okay, one of the key features of a hyperbola is when you graph it, it has asymptotes. Okay. I'm going to graph a simple one like this. It has asymptotes and it has 2 branches or 2 parts to it. Okay. This is an up-down parabola. I mean hyperbola. Remember, a parabola only goes up or down, one or the other. A hyperbola goes up and down. Okay. There's also a hyperbola. Let's look at the asymptotes again. Okay, it has asymptotes. A hyperbola also could go sideways, like this. Okay, now, what makes hyperbolas go up, down, sideways, whatever? Well, the equation for an up-down hyperbola looks like this. Notice if you strip away all the BS, essentially you have y squared minus x squared equals something. Something changes it. But notice what happened. First off, it's got a minus sign. Okay, it still has an x squared and a y squared. They're still all squared, but it's got a minus sign in the middle. That's what gives it away as a hyperbola. Notice something else. When the y was positive and excuse me, when the y squared was positive and the x squared was negative, that's when your hyperbola opened up in the y direction, up, down. That's when y was the positive value. If you look over here, the equation for this would be x minus h quantity squared over a squared minus, again, it's a hyperbola, so it has a minus, y minus k quantity squared over b squared equals 1. If you strip away all the excess BS, this just simply becomes x squared minus y squared, again, equals something. But it's the key is x squared minus y squared. Again, x squared minus y squared. Okay, the minus is what tells us it's a hyperbola. The fact that they're both squared and minus is hyperbola. And in this case, because x is positive and y is negative, this shape opens in the x direction, sideways. Okay, x direction sideways. Now, there's some trickery with the asymptotes. And I want to do one problem very quickly and then tell you not to worry about it. Don't panic. I want to do one problem very quickly. So basically, this is the key idea for a hyperbola. Okay, it's got a minus sign. It's got x squared, it's got y squared, but they're being minused. That tells you it's a hyperbola. That tells you there are asymptotes. So let's make up a problem. Suppose we had x plus 1 quantity squared over 1 squared minus y minus 3 squared over 5 squared equals 1. Okay, so what? Well, a couple things. First off, I see that this is x squared, this is y squared, and this has got a big minus in the middle. So right now, I know that this is a sideways hyperbola. X is positive, y is negative. The negative is on the y. All right. I also know that my center is -1, 3. Okay, remember we talked about this a bunch of times. When we're pulling information from inside of a parenthesis like this, we do the opposite of common sense. You see a +1 for x, you write -1. You see a -3 for y, you write +3. Okay, and this is what I showed last week, and I just said, you know what, shut up, do it. Okay, I can explain it. It's just easier. 99% of students don't understand it for quite a while, but they do use the opposite idea. When you're pulling the information out of parentheses, you take the opposite of what common sense tells you. So we have that. We have something I'll call the X radius, but it's used differently than an ellipse. In this case, it's 1. And we have a Y radius. In this case, it's 5. So the way we do this is we sketch this. We say my center is -1, 3, which is right about there. And then we use the X and Y radius different than we used on an ellipse. we say from the center, I'm going to go over 1, up 5. Over 1, up 5. If I go over 1, I'm 0. If I go up 5, I'm 8. Over 1, up 5 is there. Or I could go over 1, down 5. 3 take away 5 is -2. So look what I did. I used the X radius is 1. So from the center, I went over 1. And then my Y radius was 5. I go up 5 from here or down 5 from here. Well, what that gives me is it gives me the ability to draw lines from those new points through the center. Same thing here. From the new points through the center. Those lines are my asymptote. Okay. Now, within that drawing, bounded by the asymptotes, that means the asymptotes are my boundary lines. I can't cross them. I have to draw 2 branches sideways. Okay. So what I do is I say, oh, it's going to be bounded by that and come down like that. So that would be one branch of my hyperbola. And the next branch would be something like this. Oops, wrong. It will get closer to the asymptote. I'm just drawing it bad. Now, what it does not do is touch the center. It doesn't go in and touch the center, but don't worry about it. If you're figuring out how to do this on Mom does it for you automatically. So what did I do? I found the center there. I used the X radius and the Y radius to go over and up, and that gave me enough information to draw an asymptote, which I did. Okay, so there's my asymptote. Then I drew a sideways hyperbola within those asymptotes. Okay, remember you can't cross the asymptote. So there's nothing in this area. There's nothing in this area. But there's something to the left, something to the right. That's a very, very, very basic hyperbola. Questions about that? Anyone?
How come you didn't do -1, the X radius, when you went down?
I could have. And what would have happened if I went -1 up 8 or up 5, which would be there, or -1 down 5, which would be there, it still would have given me my asymptotes. But these two were enough to create this asymptote, and these two were enough to create the other asymptote.
So
Does that, I'm sorry.
So it doesn't matter which way you go.
No, it doesn't matter. What if you did what you were asking? What you do is create a box. A lot of instructors talk about make the box, where you go over X, up Y, over X, down Y, backward X, up Y, backward X, down Y. And that creates the 4 corners of the box, which also creates your asymptotes. It's just a different way of teaching it. Did I answer your question or make it worse?
No, you're good. Thank you.
Okay. Anybody else? Okay. With a few changes, if this had been y squared minus x squared, then the graph would have been up here and down here. some differences, but I don't want to get into those details right now. Okay, anyways, that's a hyperbola. Now, there is another hyperbola. I need to erase this. Is anybody taking this down? You guys got all this in your notes? Okay. There is another hyperbola. Instead of this up, down, or left, right hyperbola, there is a hyperbola that does show up in your future classes. Hyperbola. It's a special type of hyperbola, and this does show up often in future classes. And that's written as xy equals k, where k is some number, or if you divide both sides by x, y equals k divided by x. And again, k is just some number. K stands for some dumb number. I'll show you an example. So you might see it this way. Notice in this case, the x is dividing into the k. Okay, so it's seen either this way as x times y equals k, or sometimes it's seen this way: solve for y, get y alone, y equals some number divided by x. All right, I'll show you how you do it. It's really, really simple. Let's take an example. Let's take xy equals 8. Okay, xy equals 8. What you do is you make two tables of values. I'm going to walk you through this, okay? Two tables of values, okay? And you just pull up enough to get a basic idea. Okay, first off, can x equals 0? Is x times y equals 8? Can you have 0 times y equals 8? No. Well, can x equal 1? 1 times what equals 8? 8. Can x equals 2? 2 times what equals 8? 4. Can x equal 3? Yeah, but it's ugly. Can x equals 4? 4 times 2 equals 8. And we're just going to go on. Can x equals 8? 1. So you don't have to do all of these. You just have to do enough of these to get a general idea. Now, I said you draw two tables because x could be -1. If x is -1, y is -8. If x is -2, y is -4. If x is -4, I'm going to skip the ugly things. Y is -2. If x is -8, y is -1. Okay, so when you're trying to graph this type of hyperbola, okay, you make two tables. One where x is positive, and you figure out what y is. Another one where x is negative, and you figure out what y is. Now, if you plot these points, okay, we said x got to be 0. X is 1, y is 8. X is 2, y is 4. X is 4, well, it wasn't 3, it was 4, y is 2. X is 8, y is 1. This branch of the hyperbola looks something like this. The asymptotes, remember on the previous example, we had asymptotes. The x and y axes as an asymptote. On the previous example, we had to draw in our asymptotes, where we went over 1, up 3, and all that kind of nonsense. In this type of hyperbola, the y-axis and the x-axis are their own asymptotes. Let's do the other side. What if x is -1? Y is -8, something like that. -2, -4, -4, and somewhere out here like this. Again, the x and y axes act as asymptotes. So we're going to get real close to the x and y axes, but never touch it. Notice also, we said x can't be 0. X cannot be 0 because 0 times what equals 8? 0 times what equals 8? Nothing. So x can't be 0. And that's why there's a break here. The graph, if you put this on like Desmos or something, well, Desmos is too fast. Okay, it just Desmos, when you type it in, it goes, there's the answer. But if you put it on a slower, like a graphing calculator, you'd see it go, and then jump up here, it goes like this. Okay, it would jump over this line. So anyways, that's a hyperbola. You will see this particular one in future classes, especially in your calculus classes. They love to use this shape every once in a while. Okay, so this is the hyperbola number 3. Remember, I told you there's 3 of them. There's the one with all the big fancy equations, and we had to figure out where the heck the asymptotes were and all that kind of stuff. And then there's this one, xy equals 8. Questions on this?
Is there like certain names for these hyperbolas?
Yeah, and I don't remember them.
Oh, okay. Never mind.
Yeah, there is. In my day, right after we invented fire, but before we invented the wheel, okay, in my day, this was known as a rectangular hyperbola, because in my day, instead of calling this the XY axes, we called this the rectangular coordinate system. Go figure. I still haven't figured out why. Okay. So because it was called the rectangular coordinate system and the XY axes became our asymptotes, this was called a rectangular hyperbola. Now, I don't know. And I've never seen anybody really worry about its name. They just say, here, graph it, figure it out, do it. Yeah. Anybody else? I'm sure it's in the reading. I'm sure you can look it up somewhere. All right. What I want you guys to try is this one. I want you to graph x, y equals -12. I'm going to erase this board in a minute, but I want you to graph x times y equals -12. And I shouldn't be recording because I'm an idiot. I forgot to turn it on or turn it off. Okay, so we're solving this problem. Ellipse, new hyperbola. I suggest that you take the bottom one, get y alone, and substitute in the upper one. I'm going to start doing it now. So that gives us x squared plus 4 times 4 over x quantity squared equals 20. This is x squared plus 4 times 16 over x squared, excuse me, because when you square this fraction, you square the top, you square the bottom. 4 squared is 16, x squared is x squared equals 20. 20. Clean it up a little bit. X squared plus, this is 64 over x squared equals 20. Now the question is, what do I do? And you're going to run into this both on the quiz and if you've been doing any mom homework at all. Okay. We talked about LCDs. If you multiply through by x squared, in other words, you want to cancel that. You're going to distribute x squared to here, x squared to here, x squared to here. You're going to get x to the fourth plus 64 equals 20 x squared. Okay. X to the fourth minus 20x squared plus 64 equals 0. Made it equal 0. Seems like in order to solve any equation with powers in it, I make it equal 0. Oh, what do I do now? Well, one of the reasons I chose this and one of the reasons I like teaching this is because it brings back a lot of things that we've talked about throughout the semester. For example, we can use a substitution. Let u equal x squared. Remember how we got rid of really weird ones? U equals x squared, which means u squared equals x to the fourth. So this problem becomes u squared minus 20u plus 64 equals 0. Okay. Now what? Well, now I'm supposed to factor it. So now you spend your time going, uh-oh, how do I factor it? Well, it turns out that if you use AC is 64, like we did here, okay, and you go, okay, I kind of know that's 8 times 8, but what if I did it as 2 times 4 times 8? And then rearranged it as 4 times 16. $64 breaks down into 8 times 8, okay? But the first 8 breaks as 2 times 4 because I want it to. And then rearrange it, put this 2 and this 8 together, and I have 4 times 16. I know 4 times 16 is 64, and I know 4 plus 16 is 20. Whoops, got to be -4 and -16. Now it makes, they multiply to make positive 64, and they add to make -20. And even better, because this was what I called an easy trinomial, the coefficient was a 1, you can factor this instantly as u minus 4 times u minus 16 equals 0. You can use the shortcut because the coefficient of the trinomial was a 1. Okay, you can use those two. You don't have to use the grouping technique. You don't have to use anything. Well, this tells me u is equal to 4 or u is equal to 16. But what was u worth to begin with? U was worth x squared. Okay, use the square root principle, square root both sides, and we get x is plus or minus 2. X is, because we square root both sides, plus or minus 4. Wow. I can actually see there was one way that we could have done this that would have made just a little bit easier, but not much. Okay, and we're not even done because we got to figure out what y is. Okay. Well, what if x is 2? Where would it be easier to plug 2 for x in? I think right there. If x is 2, 2 times what makes 4? Well, y is 2. So this is 2 comma 2. When x was 2, y was 2. What if x were negative 2? If x is negative 2, you can plug it in here. If x is negative 2, 4 divided by negative 2, y is negative 2. And I'm not going to do all the problems, but it turns out that 4, 4, and negative 4, negative 4. So this particular problem had 4 answers. Okay. Now, if I haven't put you guys to sleep yet, I need you to pay attention. This is kind of important. So hello and wake up. Okay. A lot of students like to write x is plus or minus 2, plus or minus 2, y is plus or minus 4, or x plus or minus 4, plus or minus 4. Because they like this plus or minus, they think that's a really fancy, cool way to do this problem. And they see a whole bunch of positive 2's and negative 2's. Okay, this is technically wrong. Because this implies that x could be positive 2 and y could be negative 2. When you write plus or minus 2, plus or minus 2, what you're telling the world is any combination of twosies is good. Okay? So you're saying, hey, x could have been positive 2 and y could have been negative 2. But look over here. How could x be positive 2 and y be negative 2 and get an answer of positive 4? It can't. So be very careful. I know a lot of books, a lot of students, a lot of instructors like to get lazy and just go plus minus because it looks cool and it looks fancy, but it doesn't always work. So you need to be careful before you just throw plus minus. You'd be much safer just to list all 4 of these as your answer and forget all the fancy stuff.
Professor, I have a question.
Yeah.
For the 4, wouldn't the y's be 1 and -1, not 4 and -4?
Oh, you're right. Thank you. God. 4. Shoot. 4 and 1 and -4. Damn it. And -1. Better? I'm sorry. I've got it right here in my notes and I was trying to skip steps. Thank you very much. You got me. Okay. I like this problem because it involves all kinds of learning that we've done the entire semester. We had to use substitution. We had to clear fractions. Okay. We have some pretty ugly factoring to do where we had to use substitution again. Okay. And we had to remember to get a bunch of plus or minuses, and then we had to be careful about how we utilize the plus or minus. And pointing fingers at myself, I got to remember to stop doing work in my head because I screw up. Any questions on that one? Like I said, there is an alternate way that's a touch easier, but not much. So this is a good way right here.
So is the answer the ordered pair or x equals ±2 and x equals ±4?
No, the answer, okay, this is yes. The answer is these 4 ordered pairs in solution set, because remember, we're trying to get an x and a y. So when x was 2, y was 2. When x was -2, y is -2. And so on. Okay, when x was 4, y is 1, -4, -1. So your answer is only these, because we always want to solve for x and for y. Did I answer your question?
Yep.
Okay. All right. Let's take another one. This is slightly easier. Oh, the other thing I wanted to point out is right here, guys. Remember this one? This was chapter 9. When you take the square root of both sides, you introduce a plus or minus into the problem. When you take the square root of both sides, you're going to get a plus minus. That's how come we got so many answers. Next problem is going to have the same concept in it. So 2x squared plus 5y squared equals, what do they go, 22, and 3x squared minus y squared equals -1. So I won't erase the board yet. I'll leave that up there, but that's going to be the next thing. We're going to try and solve the system. You are trying to get x's and y's. Okay, so I'm going to use a different technique. The last problem we did, I used substitution. Okay, this time, remember we talked about how we could multiply an equation by any number we wanted to. I'm going to choose 5. In this case, the top equation is going to stay whatever it was. I'm not going to change it. But the bottom equation is going to become 15x squared minus 5y squared equals -5. Because I noticed that if this were a -5 and this is a +5, if I added these two together, my y squareds would drop out. Now, I'm not saying this is the only way to do this problem, okay? But I do need to show you, or remind you rather, of alternate algebra techniques. So if we add this together, 2x squared, 15x squared is 17x squared. The y's drop out, equals 17. That's kind of cool. Huh. Divide both sides by 17, we get x squared is 1. take the square root of both sides. Remember my warning, when you take the square root of both sides, you introduce a plus or minus. Okay, plus, minus, and the square root of 1 just happens to be 1. Now this is a little tricky here. Okay, before I go on to the rest of this problem, is this okay with everybody? Do you understand why I multiplied by 5? Okay, again, that always bugs students because it feels like I just pulled that out of thin air. Do you understand why I square rooted to get x alone? Okay, and how they plus or minus this there. Okay, so now we go with the game. This is a little bit ugly. Okay, if x is 1, if x is 1, so we have 3 times 1 squared minus y squared equals -1. Well, that's 3 minus y squared equals -1. Take 3, so I get -y squared equals -4. Divide by -1, y squared equals 4. Square root both sides. Too much talking. And I get y is plus or minus 2. Whoa. So when x was 1, y could have been a positive 2, or y could have been a -2. When x was 1, y could have been a positive 2, or it could have been a -2. That's what my algebra says. Okay. If we do it again, if x is -1, it turns out, I'll move out of the way in a minute, that this problem becomes the same. Notice -1 squared is 1 times 3 is still 3. At this point, the two problems are exactly the same. So when x was -1, we're going to get two answers. We're going to get the same two answers. Y is plus or minus 2. So when x is -1, we have a 2, or when x is -1, we have a -2. Okay. In this case, it is okay to say plus or minus 1, plus or minus 2, because this says, this answer that I've just put in a circle around says all possible combinations of +1 for x, or of 1 for x and 2 for y, are okay. X could be +1 and y is 2. X could be -1 and y is 2. X could be +1 and y is -2, -1, -2. So this time it would be okay to write plus or minus, plus or minus. However, if you don't want to take the chance, this is just a good answer. Okay, doesn't look as sophisticated and fancy, but this is just as good an answer. Questions? Remember, if you've looked online, I gave a breakdown of what's going to be on example 4. It's going to be 2 problems that ask you to solve systems, just like I've done here. They won't be exactly the same, but they'll be similar enough. Okay, no questions? All right. Then changing topics completely, totally. Okay. There was a worksheet that I asked you to do. This is 30 degrees, or I suggested you do. And I'll be happy to go over that if somebody wants me to, but right now I want to work over this. What is this? 6. Okay. These are what we called special triangles. 30, 60, 90, 45, 45, 90, 30, 60, 90. Find the missing sides. So go ahead, spend a few minutes finding the missing sides. Okay, one of the things I would definitely put on your 3x5 note card is the relationship of a 30, 60, 90 or 45, 45, 90 triangle. In a 30, 60, 90 triangle, the side opposite the 30 degrees is called A. Okay. The hypotenuse is always double A. Always. And the side opposite the 60. So if this is 30, has to be 60. This is A times the square root of 3. That's the relationship that the three sides of a 30, 60, 90 triangle always have. But they start with the side opposite the 30-degree angle is your smaller side. It's always called A. The hypotenuse is double A. All right, well, look at that. That gives us an equation to solve. If 7 has to equal 2A, divide, then 7 over 2 is worth A. So let's draw this triangle again, just so you can see it. This was 7. This has to be 7 divided by 2. And if you said 3.5 or 3.5, I don't care. They're all the same. I'm happy with that. Now, this side up here has to be A times the square root of 3. So 7 over 2 times the square root of 3, which makes it 7 square roots of 3 over 2. And that would be the missing sides for that triangle, according to the pattern. Is that okay with everybody or not? Okay, guaranteed that question. Let's come over here, do the other 30, 60, 90. Okay, again, 30, 60, 90. This side opposite the 30 has to be the A. The hypotenuse is 2A. And the side opposite the 60 is A times the square root of 3. So that gives us our equation to solve. A times the square root of 3 equals 6. You divide both sides by the square root of 3 and get A equals 6 over the square root of 3. But, okay, you can't have that. Remember, we have this rule for algebra that says in your final answer, you can't have a radical in the denominator. That's also going to be final exam question. I'm going to give you a bunch of radical denominators, and you got to figure out how to clean them up. So the one way we've talked about that is to multiply top and bottom by the square root of 3, giving us 6 square roots of 3 over the square root of 9. But the square root of 9 is 3, so final answer 2 square root of 3. And that was A. Okay, so A is 2 square root of 3. So let me redraw that over here so we can see it. Okay, this was 30. This was 6. And we just figured out after cleaning all this up, this is 2 times the square root of 3. And the hypotenuse will be 2 times A. So if we multiply this by 2, it'll be 4 times the square root of 3. So is that okay for number 3? Again, there's a worksheet in the chapter 11 module, and it has the answers. It's got a bunch of 30, 60, 90, and 45, 45, 90 triangles. And it's got the answers there also. All right, before I do number 2, okay, so somebody has any questions, I'll do number 2 in a minute. I want you to look at number 3 again, the answer, find the area and the perimeter of this triangle. Find the area and the perimeter of this triangle. All right, so let's go with the area. Way back at the beginning of the semester, I give you a whole list of formulas that I said you should know these in your sleep by heart because they'll come back and bite you. Area of a triangle is one of them. Now there's 2 formulas for area of a triangle. It's either area is 1/2 base times height, or area was base times height divided by 2. Whichever seems easier for you, they'll both give you the same answer. But here's the question. Well, I'll just do it. It's 1/2. The base of this is 2 radical 3. Okay. And the height is always measured at right angles to the base. This hypotenuse is not the height. Okay, I don't know if you guys ever remember going to your grandmother or grandfather's and they say, oh, what a big boy or a big girl you become. You know, and you're slouching against the wall and they say, stand up straight. I want to see how tall you are. Well, it's the stand up straight that tells you your height. It's not your slouch. Okay, it's your stand up straight. The base times the height, stand up straight. So it's 1/2 times 2 radical 3 times 6. Now, that's whatever, that's going to be the answer. But here's what happens. A lot of people, a lot of students, for some reason, distribute the 1/2 here and here. And I don't understand why. The distributive property would have to be something like 2 radical 3 plus 6. To utilize the distributive property, you have to have a plus or a minus inside. Then you go 1/2 times this thing, 1/2 times the 6. Okay, so a lot of students, for some reason, distribute the 1/2 to everybody, and that ain't the case. This is, if you recall, our rule for multiplying radicals was outside times outside times outside, 1/2 times 2 times 6, and inside times inside, radical 3. Okay, so this becomes 6 radical 3, and technically it's square units, whatever those are, inches, feet, meters, miles, whatever. Okay, so that's the area of this triangle, this particular one. 1/2 times base times height, that formula way back from the beginning of the semester. Okay, and then multiplying together correctly. All right, the perimeter is real simple. The perimeter of a triangle is just add up the 3 sides. So the perimeter, I'll move out of the way, is 6 plus 2 radical 3 plus 4 radical 3. Okay, just add up the two sides. Now it turns out that over here, these are called like terms or like radicals. So we can add them. So now you go, oh, whoa, way back in chapter 8, intermediate. Remember, there's 2 chapter 8s. There's 8 elementary, there's 8 intermediate. Way back in chapter 8, intermediate, we said when you're adding radicals, you add the coefficients. 2 plus 4 is 6, radical 3, and bring down the 6. These are not like terms, so you can't add them, and that's your answer. Inches or feet or miles or whatever, I don't know your units are. Okay, so there's perimeter, there's area of this triangle. Is that okay with everybody? Okay,
Yes.
last problem on this assignment. I want to find the legs here. So it turns out that in a 45, 45, 90 triangle, the 2 legs that are opposite the 45-degree angles are both called A, and the hypotenuse is A times the square root of 2. Okay, that's the formula. Again, put that on your 3x5 note card. In a 45, 45, 90 triangle, the 2 legs are the same, A, and the hypotenuse is A times the square root of 2. Well, there's our equation. 6 equals A square root of 2. Divide both sides by the square root of 2 to get A alone. Okay, and then you go, oh, I gotta rationalize the denominator. Okay, so this is 6 radical 2 on top over 2, divide 3 radical 2 equals A. So this was 3 radical 2, this was 3 radical 2, and you're done. Okay, that took a little bit longer than I wanted. All right, let's take about a 5-minute break. I want to come over and do a max problem, projectile motion, where a rocket gets launched into the air, find out how high it goes. And I want to start practicing how to graph parabolas, okay, ellipses, circles. I got a bunch of stuff. We'll just see how far we can get tonight, okay? So about a 5-minute break, and then we'll come back and we'll do a projectile motion, a rocket problem. Okay, I'm going to put up a couple of problems, and by the end of 3 or 4 of these, we should be pretty much dead. So we'll see what happens. I want you to graph this shape. I want you to label the vertex, the x-intercept, y-intercept, the equation of the axis of symmetry. Not just put the axis of symmetry in, but what's this equation? The reflection point, if you're not sure, I'll show you this later. And then try to state the domain and range, if you can. Now, very important, you need to recognize what shape this is. When I started tonight's lesson, I gave you a whole list of potential conic sections, graphs, a whole list of these. Well, if you multiplied this mess out, okay, essentially, this would be y equals x squared with a lot of other junk. Yeah, I know there's a 2 there. Yeah, I know there's a -6. But forgetting all of that stuff, just focusing on the really important part, this is y equals x squared, which means it's an up parabola. It'll look like that. This is an up parabola. So everything you do over here, where's the vertex? Where's the x-intercept? All this junk, okay, should be in context. Where's the vertex of the parabola? What's the x-intercept of the parabola? Okay, so with that, I give you a few seconds to try this. Okay, so here it goes. The A value is +2. That's what told me it was going up. Okay, I already know it's a parabola. My vertex is 2, -6. Again, when you're pulling information out of a parenthesis, you take the opposite of what you see. I see a -2, I write +2. But the 6 is not in a parenthesis. So I see a -6, I use a -6. All right, there's my vertex. Y-intercept is easier, so I'm going to do it next. Okay, the Y-intercept implies X is worth 0. So you plug it in. Y equals 2 times 0, take away 2 squared, -6. That's 2 times 4 minus 6. That's 8 minus 6, which is 2. So when X was 0, Y was 2. That is my Y-intercept. Okay. My X-intercepts means set Y equal to 0. So if I do that, I'll move out of the way in a minute. Okay, so I've taken this equation. I want to find the X-intercepts. So I set Y equal to 0 and I get this. Now I have to solve it. We talked last week. There's a bunch of ways you can solve this. One way is you could square this out and then try to refactor it again. The quickie way is to use what was called the square root principle. Okay, if I add 6 to both sides, divide by 2, okay, now's where the tricky part comes in. To get of a square power, the only thing you can do is square root it. But when you do that, the square root principle says, oops, got to put a plus or minus in front of that. Okay, and here we get X minus, oops, come on, Foster, equals X minus 2. So add 2 to both sides, and we get a final 2 plus or minus the square root of 3 equals X. Okay, the rest of this I can do after the graph. All right, any questions on my math? I haven't sketched it yet. Any questions on how I knew it was going up? Or how I got the vertex? Or got the Y-intercept, or got the X-intercept? Any questions on my algebra? Okay. Then let's sketch this. Where's my, okay. So my vertex is 2, -6. Remember, it does not have to be perfect or even close to being scale. Well, it should be close. Okay, so I know from there I'm going up, okay, and down. My Y-intercept is 0, 2. Whoa. Y-intercept is 0, 2. So look at this. This is a pretty skinny U going here. Now, how skinny is it? Well, the axis of symmetry goes right through the vertex. Okay. Its equation, look right here, is X equals 2. It's a vertical line. So it's got to be x equals always that part of the vertex. So what did I do? I created a situation where I can calculate the distance from this y-intercept to the axis of symmetry is 2. So its reflection has to also be 2. From here to the axis was 2. So this has to go over to find its reflection. 2 and 2 is 4, 2. That's the reflection point. Okay, connect the dots. It is not a sharp V. It's actually a rounded curve down there at the vertex. Be very careful. It's not, it doesn't come to a point. It's very rounded. Couple things here. We're almost done. The X intercepts are here, and they are 2 plus the square root of 3, 0. That's that one. And this one is 2 minus the square root of 3, 0. That one. Now I'm almost done. I still have to do domain and range. Any questions? Okay. Domain is all possible x's. I'm just going to write it down. Okay. The domain is all reals because this parabola ultimately opens up wider and wider and wider and wider. And so we're using all the x's on the number line. You have two ways of writing that, either a fancy scripted R, or you can say from negative infinity to positive infinity. That's the domain. The range is from -6 up. The range is all y values, all possible y values. So it's bracket -6, infinity. Okay. There's good chance that that's the question on the test. Almost exactly like that. Any questions on any of what I did? I kind of went fast over the reflection point. That's there so you can get a more accurate graph. Okay, it's really easy to find. Anybody? No? Okay. Now, one thing I want to point out, this was what most of us as students remember of a regular parabola. This is going up. The other one we studied the other night was a sideways parabola. Okay, so I want to let you try that one. I'm going to erase this stuff here. You're going to do the same stuff, label everything that I have here, but I'm going to give you a new equation. New equation, x equals 3 parentheses y minus 1 squared minus 18. Okay, I'm going to erase the rest of the board in a minute, but that's the parabola I want you to graph and label all that junk that I just said. So again, about 5 minutes to give you that. Okay, so again, if you look at this one, if you multiplied out all this mess on the right-hand side, you'd get y or x equals y squared. Okay. Basically, that tells us it's a sideways parabola. Remember the one we just did was basically y equals x squared. So that was an up or down parabola. Okay, this is a sideways. Because A is +3, it's opening in the positive direction. That's positive. So it's sideways, positive. My graph should be going that way when I'm done, if everything is good and I haven't done anything silly. All right. So we worked that one out. My vertex, be careful. My vertex is -18, 1. Remember, the vertex is x, y. When you write an ordered pair, the first number is always the x, the second number is always the y. It's the equation that's backwards. So this 1 is with the y in the parentheses. So when we pull it out, we pull out the opposite. So we pull out +1, but it goes into the y position of the ordered pair. This is left to be the x. That's the only thing it can be. But because it's not in parentheses, we just use it as it is, -18, 1. Okay. This time I'm going to do the X-intercept because it's easier. X-intercept. I'll eventually do the Y-intercept, but the X-intercept implies y is worth 0. So I'm going to have x equals 3 times 0 minus 1 squared minus 18. That's 3 times 1 minus 18. That's -15. So my X-intercept is -15, 0. Again, remember, okay, the first number is the X value, the second number is the Y value. So we said Y was 0, so the second number has to be 0. All right, let's try the Y-intercepts. That means X is worth 0. So I have this equation, 0 equals 3 times y minus 1 squared minus 18. And again, you could multiply the y minus 1 squared out. You could reorganize it. You could use the quad formula, or you can take the shortcut, add 18 to both sides, divide by 3. Take the square root of both sides and remember the plus or minus. Add 1. So I have 1 to both sides plus or minus the square root of 6 equals y. And I think I have enough information here now to graph this sucker. So before I do the graph and all that stuff, any questions on my algebra? Do you know why A is +3 and why that means the direction it goes? Okay. Did you understand how I got the vertex? That was a little tricky because it was a sideways one. So everything is weird. To calculate the X-intercept, I set y equal to 0 and just did arithmetic. To calculate the Y-intercept, I set x equal to 0 and had to solve it. Again, there was more than one way to solve it. This is the easiest way. All right, so we graph it. No questions at all, you sure? Okay, then, okay, my vertex is negative 18, 1. Whoa, negative 18, 1. Vertex, negative 18, comma 1. Whoa. And I know it's going that way. Okay. The X-intercept is negative 15. So if that's negative 18, here's negative 15, comma 0. That's an X-intercept. Okay. Axis of symmetry goes through the center, but this time it's a horizontal line. So this time its equation is y equals 1. Horizontal line, y equals. When it was a vertical line, x equals. Okay, well, that gives me my axis of symmetry. I have that, so that distance from 0 to 1 is 1. So it's going to come up here, 1. So I have negative 15, up 1. So this is negative 15, comma 2. And that gives me my picture. So graph it, zingo like that, zingo like that. This point right here is 1 plus radical 6. And this point right down here, I'll move out of the way, is 1 minus radical 6. Oops. Okay, good enough. Oh, I should put arrows on here because the graph goes forever. Okay, I still have to do the domain and range. But that's pretty much 99% of all the work. Any questions? Okay, still got to do domain and range. So the domain is all possible x's. X's start at negative 18 and go forward. So in this case, the domain is bracket negative 18, comma infinity. Goes from negative 18 forever this way. The range, okay, kind of tricky. This graph opens up, you just have to trust me, but the graph keeps opening up wider and wider and wider and wider, even though it's sideways. So the y values ultimately contain everything. So in this case, the range is either fancy R, or you could say negative infinity, positive infinity. It doesn't matter. Okay. That's it. That's a sideways parabola. I was going to go 2 more problems, but I'm getting burned out. I'm assuming you guys are also. So I want to do 1 more problem for tonight. Then we'll come back, answer all your questions tomorrow night. Tomorrow night will be nothing but review your questions. I have some more problems to do, but you'll have plenty of time to ask me questions left over from tonight, left over from mom, anything. Okay, but I do want to do 1 more problem tonight. So questions on this work up here? All right, then last problem of the night. It actually has 2 parts, so I lied. But Okay. A rocket is launched into the air. Its height is given by h of t equals -16 t squared plus 128 t plus 48. And let's say we're talking about h equals feet and t is seconds. Just for our units. So its height in feet is given by this formula regarding time, which is measured in seconds. So the first question, part A, what is rocket's maximum height? Question mark. Okay, so I will pause while you kind of think about that. Okay, so if you don't know it by now, I mean, this we need to help you. What this is, think about this. First off, we've talked a lot that 48 means that's where it's being launched from. So it's being launched from a little hill that's about 48 feet tall. It goes up, it comes down. Okay, the max height is at the vertex. So the vertex is equal to the max point. If for some reason this was going down and then coming up, this vertex would be the minimum height. Okay, but for us, the vertex is the max height. What we need to remember is when the equation is written in this way, the vertex is negative b over 2a, comma, plug it in. So when the equation is written like this for a parabola, okay, then this is the formula we need to know. Again, that's something that you should put on your note card, but put it in context. The equation has to be like this. The equation has to be something like y equals ax squared plus bx plus c. It cannot be that fancy junk like this. Okay. This formula only works when the equation looks like this. All right. So how's this work? Well, negative b, that's negative 128 over 2 times negative 16, comma, something. All right. So what's 128?
4.
4. That's what I'm hoping. 4. Now, some people, when I introduced this last week, got confused. I'm sorry.
-4, my bad.
Oh, it's got to be positive 4.
Oh.
Because it's a negative divided by a negative.
Yeah, you're right. Sorry, I forgot the negative.
Yep, it's your bad, but yeah, you're it's got to be positive. I'm sorry. I'm getting wacky and getting kind of silly right now. So a lot of people didn't know what to do with that number. Once they got 4, 128 divided by 16, whatever is 4, they didn't know. Well, what we're doing is we're plugging it into here. We're just doing arithmetic. So we're saying this is negative 16 times 4 squared plus 128 times 4 plus 48. Okay, you're just plugging this 4 in place of t in this equation. So what do we get?
304.
Can anybody confirm? Did anybody else get 304? Nobody wants to volunteer. All right, I'll work it out and see.
All right.
Somebody else got it or not?
Yes, I got it.
You got it. Okay, 2 people got it. Okay, that's good enough for me. Okay, so we got this. Now, the question is, what does that represent? In pure algebra, you go, well, that's the vertex, 4, 304. So what? This isn't pure algebra. This is a word problem. So the 4 represents the time, because our x-axis, what used to be the x-axis, has become our time axis. So this is time. Okay. Our y-axis has now become our height axis. So this is height. Okay. So the question says, what is its maximum height? The answer is 304. What are our units? Feet. The max height is 304 feet. Max height. Now there's a lot of algebra and a lot of learning in this one simple problem. Okay. Another thing is, by the way, how did you know the rocket goes up and down? How did you know it was a down U? Well, common sense says, hey, something goes up and it comes down. It makes a U-shaped curve. But we've learned in algebra that when your coefficient of the parabola is negative, it's a down parabola. So it all kind of fits together in some way. All right, that's part 1. What's its max height? Part 2, when does it reach 160 feet high? That's bad English, but it's okay. So that's part 2. When does it reach a height of 160 feet? I'll pause and let you think about that. So while the recording was off, I did this. We had set H equal to 160. I moved everything to the left-hand side because I like my t-squareds to be positive. That's just an idiosyncrasy on my part. I noticed with a little bit of work that everybody divides by 16. So I divided to factor it out of 16. Okay. And then I factored this trinomial. It was easy factoring, use the AC, but whatever, it factors into this. Okay. And I did it quickly in my head. You might have to go to your scratch paper to do that, but t squared minus 8t plus 7 factors into t minus 7, t minus 1. Solve it, we get these 2 answers. Now, in the past, I've tricked you. Okay. We've always had somebody that rejected somehow. This gives us 2 answers. What this is saying is, okay, at 2 times, okay, the height is going to be 160 feet high. Do either of these reject? This is saying at 1 second, the graph will be 100, or the rocket will be 160 meters. And at 7 seconds. The graph will also, or excuse me, the rocket will also be at 160 meters. So these seem to be okay answers. Okay, and we already know that at 4 seconds, which is kind of like right in the middle, it'll be at 304. So that seems all reasonable. So at 7 seconds and at 1 second. And those are your two answers with units. All right. Tomorrow night, I want to talk about graphing circles, ellipses. I want to talk about using completing the square for a circle, completing the square for an ellipse. I want to talk about the midpoint, the distance formula, the slope formula, the equation of a line. Tonight, we covered about 2/3 of exam number 4. Tomorrow night, I want to finish off, answer more of your questions. So come tomorrow night with a lot of questions. It's boring just to sit here and listen to me. I know I'm bored. I listen to me. So with that, see you guys tomorrow night. Bye-bye.
All right, thank you, Professor.
Bye-bye.
I got a